Hi, this is Professor Poyo, and we are here today talking about Chapter 10 in our math book, which is actually data analysis and statistics. It's just a touch on that. It's a beginning overview of data analysis, and it's really important for you as an educator especially to understand the functions of data. In other words, how to obtain data through assessment of your students, but also how to communicate it and display your data in order to get whatever point is across that you need to get across. Here's 6 examples of visual displays of data that you are probably familiar with. We see pictographs, we see histograms, bar charts, a double line graph, a pie graph, and also a dot plot. And we're going to go through each of those individually in just a minute or so. But notice that all of these are functional in the sense that they do communicate data in a picture form. Some of our academic language, notice that the first half of this PowerPoint, we're actually going to be just talking about how to display data. Now, some of the questions you're going to ask yourself is whether or not a particular type of graph is appropriate for the data that you have. For instance, once I collect some data, say it's test scores on my students, would I want to display them in a circle graph, or would it be more appropriate for me to use something like a stem and leaf plot? So we're going to talk about each of those individually. Now notice that the second half of this PowerPoint actually deals with measures of central tendency and variation. I'm sure that many of you are familiar with mean, median, and mode. When we talk about our average, say the average temperature, that's probably something that we deal with the most in our day-to-day life. We're also going to create box plots and talk a little bit about normal curves, percentiles, standard deviations, and mean absolute deviation. When we talk about pictographs, there's a couple of features of the actual pictograph that are important in the sense that, first of all, it can show categorical information. It can also show frequency of your data. The most important thing to notice, though, about pictographs is that it has to have some sort of a key. There needs to be some symbol that represents a particular quantity of items. So, for instance, right here we see that Isabella sold 40 boxes. Now here's where we put her name, Isabella, and if we note down here that the key is 5 boxes, then that would indicate we would have to draw 1 cookie here for every 5 boxes. Well, if Isabella sold 40 boxes, then we're going to have to draw 40 divided by 5, or 8 actual cookie symbols here, in order to display the data of how many boxes of cookies Isabella sold. So let's see, do we have 8 there? Yeah, sorry, they're not exactly perfect cookies, but you get the point. All right, Emma, on the other hand, she only sold 15 boxes. So when we think about how many of these symbols we're going to use for Emma, we count by 5s, since each of these cookies represents 5 boxes. Then we can write 5 of these, and if you want to add the little chocolate chips, you can do that, but kind of takes a little bit of time with this pen here, so I'll let you do that on your own. And then for Sam, if he sold 35 boxes, we're going to ask ourselves, okay, 35 divided by the 5, since each cookie represents 5 boxes, would mean 7 cookies for Sam, and then Grace, since Grace sold 50 boxes, we would have to write how many boxes for Grace. Let's see, 50 divided by 5, that's right, 10. We would put 10 cookie symbols here to represent how many boxes of cookies Grace sold. So pictographs are really good when you don't want to actually include the frequency. Like if you have a high frequency, say like for instance here, 50 boxes, you wouldn't necessarily want to have to draw 50 X's or something to that effect. So come up with a symbol that will represent a specific amount, and you've got it made. The other thing you need to make sure that you include when you have a pictograph is some sort of a title, and then obviously this legend or key. Those are the most important. The next type of display data that we're going to look at is dot plots or line plots. These are a very quick and simple way of organizing your information. And again, we're talking about frequency here. We're talking about how many of something, one item, one variable, one factor, each of these x's represent. So for instance, this example right here, the numbers represent the number of pets, and the x's represent the households with that number of pets. Now, most likely, if you didn't have this written down here at the bottom of your dot plot, you would actually write it in over here, as far as this is the number of pets and the x's represent the number of households. So you've got your vertical axis representing the number of households, your horizontal axis representing the number of pets. So just by taking a quick look at this, can you tell what is the most frequent number of pets? Okay, it would be right here, one pet. And the reason we would say that that is the most frequent is because it has 1, 2, 3, 4, 5, 6 x's, which represents right here the number of households. So 6 households only have one pet. All right, so that's the most frequent. Now the least frequent, there's actually a tie, other than these that have nothing next to it, but 6, 8, 10, 13, and 14. All of those would be the least frequent. They only have one X, which means only one household actually has that number of pets. Don't know how many pets you have, but at my house we have 2 pets, so I would put my X right here. And if I did that, then there would be a tie between having one pet and 2 pets as far as the number of households. But I'm not the one who, I actually don't have my data included in here, so I would have to erase that. Yep, and that wouldn't really count. Okay, so some of the academic language that I'd like for you to notice here is outliers. And if you look, it's right here. Now, outliers are any data points whose value is significantly greater or less than the other. So in this case, these two right here are pretty significantly different from the rest of the data. So we could consider these outliers. Now later on in the PowerPoint, I'll explain there's an actual formula that you can use to determine whether or not something is an outlier, but as a general rule, oftentimes you can eyeball it and just look at something like this type of display, and determine that these are far enough away that they are significantly greater than the rest of the data points. A cluster would be something to the effect of this, right in through here. All of these are clustered together, and typically you'll have a cluster perhaps that looks like this, or maybe you'd have something like, you know, a cluster over here where these are all together. Let's see, let's add a few more here. And since this is all together, then this could be also considered a cluster. Okay. A gap is where you see a large space between points. So right here, this would be considered a gap. Okay. Now the mode is your data score that appears the most often, and we'll talk a little bit later about mean, median, and mode, but as far as this display is concerned, our mode would be 1 because that's the most frequent. It's the data score that appears the most often. Another visual display of data is called a stem and leaf plot. What I'd like to do with you at this point is just kind of walk through the steps to making or creating a stem and leaf plot. It may look complicated just by viewing it like this, but as we go through each step, I think you'll see that it's not really complicated at all. First of all, you would have to have a set of data in order to start your stem and leaf plot. In this case, I don't have the actual numbers written down for this example here. However, if you look at this example, right here, this is a stem and leaf plot. Here's your data set. Notice that the data set right now appears without any type of order whatsoever. All right, the first step is to make sure that you get your data in order. It can be least to greatest or greatest to least, it doesn't matter, but you need to organize your data. So let's move back over here. You're going to make the stem by writing your tens digit from least to greatest. So for instance, this 4 is going to represent a score of 40 something, or in this case, if we look at the key, we see it's inches. So this is going to be 40 something inches. The 5 represents 50 something inches, and the 6, 60 something. The second step is to make the leaves by writing whatever digit is in your ones place. So for instance, this, a 4 and an 8, would represent 48 inches. That's one of my data. My next data would be a 49. The 4 is in the tens place, the 9 is in the ones place. Moving into the 50s, I've got 54, 55, and 58. And then finally, 60 and 63. Now notice, I don't have a 56. So I don't put my 6 here at all because there is no data that represents the number 56. Finally, our third step is to draw your actual line here across. You can do it like this if you'd like, put your title here. You can actually write stem and leaf if you want to, but that's not necessary. This, however, is absolutely necessary. Without a key, again, you cannot read a stem and leaf plot. Very similar to a pictograph. So here we would write a 4 and then put our line here, and an 8 means 48 inches. Now, you wouldn't have to necessarily use 4 and 8. This is the first piece of data, or the first actual number in our data set, but you could use absolutely any number. I could have said, okay, I want my key to be 5, draw my line, and 5. And then I would have to indicate that that means 55, and I have to say inches because that's what my data represents, as we can see right here, inches. Okay, so looking at this stem and leaf plot, here's my data set, and this is how I would set up my stem and my leaves. So all of these represent tens digits, all of these represent my ones digits. So for instance, my lowest score right here is 63, whereas my highest score is 100. Tens place, you're going to put a 1 and a 0. If you had a score of, say, 200, you would put a 2 and a 0 here to represent your tens place. Typically, though, stem and leaf plots are used for scores or for data that are 100 and less. That's just, so this is not something that you frequently see. But again, here's my key. Very important to put the key there. 71 means 71, and I would say probably a score of 71. Right here, this stem and leaf plot again shows us this is the stem right here. Those are the tens digits, and here's my leaves. All of my leaves represent the ones digit or the ones place. So if I were to say, just by looking at this stem and leaf plot, I can tell you what my mode is, what occurs the most often. And I know that because I see 3 2s here in a row. Okay, so what that indicates is that if I were to write out all of these, the actual data set, I would have 52 appear 3 times. 52, 52, 52. All right. Another frequent score here would be 25. Notice that I have two of those, two fives, which indicates that I would have 25 listed twice. I would also have 32 listed twice, 43 listed twice, as well as 47. Okay, remember though that if a number doesn't exist, you don't write it in. For instance, I don't have 70. 70 is not one of my scores, so I don't put my 0 here. I'm not trying to put these in numerical order other than numerical order of how they actually appear. And then this needs a key, something that's not appearing right now, so we'll write it in ourselves. So I can pick any of the data. I'm going to say my key 2 and then my line, and I'm going to put a 5, and I'll write means 25. Well, I would write 25. Hold on, means 25. There you go. All right, our next type of data set visual display would be our grouped frequency tables. Now notice over here I've got 4 different types of displays written or included. We've got histograms, bar graphs, double bar graphs, and circle graphs. When we talked about, or as we're talking about grouped frequency, I'm going to show you this example here. Anytime you draw a frequency table, you have to include the actual frequency itself. Otherwise, it's not a frequency table. Oftentimes, there'll be a range here, and the range indicates that it's grouped. Grouped frequency means that you're putting more than one piece of data together. In other words, all of my scores that are in the range of 90 to 100 will appear right here. So I have 4 scores that are in between 90 and 100. Here I have 80 to 89, and my frequency is 8. 70 to 79 is 4, and so on. The ranges are assigned to a data set, and the number of scores that fall within each range is listed then. So for instance, we're using right here our standard grading scale of A, B, C, D, and F. And if I were to take all of my scores that appear here and group them according to the range of our typical grading scale, I would come up with 2 is the frequency. That's how many are scores between 0 and 59. All right, so here's my 59. So I would look at all of these right here. Whoops, sorry. All of these are what would be considered 0 to 59 or an F, and there's only 2, fortunately. Now, a D, on the other hand, is 60 to 69. So I'm just going to look at these right here, and I see there's 2 of them. All right, and then as we continue, 70 to 79 is 4, and these all fall according to what I had them written in our frequency table right here. So our next slide is going to show you how then to create histograms and bar graphs. But what's the most important thing to remember is that you've got to get them in. You have to take your data set and make a frequency table first. That's always the first step, the frequency table before you start to create those histograms. Okay, now, if you look at these 2 examples, this is a histogram, this is a bar graph. Okay, notice they don't look the same. Well, there's a real important reason why they don't look the same, and it has to do with this right here. Okay, if you notice, my scale down here on my horizontal axis is continuous. I start at 25 and it goes all the way through to 74. Anytime that I'm working with continuous data and I want to group them in frequencies like this, a histogram would be a really good choice as far as a visual display goes. Notice over here, there's space or there's a gap in between each of these bars. This bar graph then does not display continuous data. The bars don't touch, and so oftentimes we use a bar graph for something like this that would be categorical. Categorical data actually has information that fits in categories like New Jersey, New Hampshire, etc. It's not numerical. Now you can use a bar graph for numerical data as well, but anytime that you're using categorical data, you're going to use your best option would be your bar graph. Now circle graphs, or sometimes called pie charts, also are an excellent way to display data. But the difference in a circle graph is that it shows how all of the parts are related to a whole. So for instance, in here, in this actual example, we can see that the amount of, or the percentage of what we do with our trash, 55%, we put in the landfill. But it's related to how much of our trash we recycle and also how much of our trash we burn. So again, you may want to think about the fact that all of these guys touch. See how each of these sections touch, very similar to a histogram, which means that all of them are related to each other. Okay, I'm going to give you a chance to practice. And we're going to practice using a grouped frequency table by creating a histogram. Already what we have right here is that grouped frequency table. And I had mentioned earlier the fact that before you even start to create a histogram, you've got to use a frequency table to set up what your data is going to look like. So let's look at this example. We've got a cappuccino coffees made at a cafe every hour. All right, so here each hour is represented by a numeral, and these numerals actually indicate how many coffees were made each hour. So for instance, the first hour they made 0 coffees. The second hour they made 3 coffees. The third hour they made 4 coffees, and so on. So we notice if we were to count up how many pieces of data we have here, there are actually 18, which means that this cafe was open for 18 hours. Here's the first hour, here's their second hour, here's their third hour, etc. And then they finally close after being open for 18 hours. It's a long time. Now, in a histogram, the data is related, and so we want to set up some sort of interval rather than indicating each one on its own. So what this example has done is taken any of the data that's from 0 to 3 and clumped it together. Any of the data that is 4 to 7. And again, remember that these numbers here represent the number of coffees that were sold. So this first histogram bar is going to represent 0, 1, 2, and 3 coffees sold. The next one will be 4, 5, 6, and 7 cups of coffee sold. The next one will be 8, 9, 10, 11 coffees sold. Notice that each of these intervals are the same. There's 0 to 3 is 4. 4 to 7, there's 4 data there. 8 to 11, there's 4 opportunities. 8, 9, 10, and 11. Same thing, 12 to 15 and 16 to 19. So very important that you have even intervals. And I don't mean even as in the number 4 is an even number, but that each interval is the same. Even intervals, really, really important. Okay, now when we come down here and look at the frequency table that they made, this is something that you don't necessarily have to do, but you can to keep yourself organized. I had said a slide or two earlier, this absolutely is necessary in order for it to be considered a frequency table. You have to have the number here or the frequency listed. So as I look up here, I've got 0 and 3, so I've got 2 tally marks. from 4 to 7. 1, 2, 3. 3 tally marks, so the frequency was 3. All right, if I'm looking at 8 to 11 cups of coffee, how frequent did 8 to 11 occur? Well, notice that there weren't any hours here that sold 8 cups of coffee. That's okay. My intervals are even doesn't necessarily mean that I have to have a data that represents each of those numbers within the interval. But I do have all of these, 9, 10, and 11. And when I count up my tallies, I have the frequency of 8. 12 to 15, again, I can see right here, there were 3 hours where they sold between 12 and 15 cups of coffee. So my frequency is 3. And then finally, my last interval, 16 to 19, notice there was no hour here where they sold 16 cups of coffee. That's okay. But I do have 2 hours where they sold 17 cups of coffee and 18 cups of coffee, respectively. So my frequency is 2. All right, what we're going to do is go ahead and create a histogram. Now that we have our frequency table created, we're going to create a histogram. So I'm going to walk you through that, and you can either stop the video now and try it on your own and then check it with mine, or you can do it as I do. All right, so we're going to set up this frequency table first of all by starting with our graph. I have to label it, so over here is going to be my frequency, okay? And what I mean by frequency is how often did it occur, all right? And in this example, it's how many hours, how many of the hour intervals, how many hours did they sell however many numbers of cups of coffee. Okay, so that's my vertical axis. My horizontal axis down here is going to be the actual number of coffees sold. Okay, here's my number of coffees sold. Now remember on the other slide, we already broke it up into even intervals. My first interval was 0 to 3 cups of coffee. So I'm going to label that 0 to 3. My next interval was 4 to 7 cups of coffee. The third interval, 8 to 11 cups of coffee sold. The fourth interval, 12 to 15 cups of coffee. And then finally, my last interval was 16 to 19 cups of coffee sold. And notice that each of these intervals are even in the sense that it represents 4 numerals. So I've got my horizontal axis set up. Let's get this vertical axis set up. When I look back at my data set, I notice that the most number of hours is 8, and the least number is 2. So somehow I'm going to have to figure out on this axis how to divide it up between 2 and 8. I think probably the easiest is just to count by 2's. So that's going to represent 2 hours, 4 hours, 6 hours, and finally 8 hours. Now my next step is to go ahead and draw in the bars. Now remember, in a histogram, our bars are, this is all continuous data, so our bars are going to touch each other. So each of these hash marks here actually represents the middle of my bar. For instance, 0 to 3 cups of coffee sold. There were 2 hours during that 18-hour day where they sold 0 to 3 cups of coffee. 4 to 7 cups of coffee sold. Well, actually, there were 3 hours during their 18 hours that they were open where they sold 4 to 7 cups of coffee. So I'm going to draw my bar right there. Now, 8 to 11 was my most frequent. And remember, whoa, sorry about that. Where it was actually 8 hours of their 18-hour day where they actually sold 8 to 11 cups of coffee. So that's going to be my most frequent. And I can tell that because that's my largest or highest bar. 12 to 15 was 3 hours, well, 3 hours of the establishments being open, and then 16 to 19 was 2. If I wanted to, I could color all of this in, and that would be fine. Or I can leave it, like it is. It doesn't matter. It's up to you. Now, the only other thing I think that I might be missing would be a title. Okay, so up here at my title, the title of my graph, I'm going to call it, whoops, sorry about that, Coffees Made at a Cafe. And if I knew exactly what cafe, I might want to actually call it by its name. Made at a cafe every hour. Now, do you remember when we first were looking at the data set, I had mentioned that the establishment was open for 18 hours? Well, if that's true, 18 hours, and this represents the number of hours and how many cups of coffee that were sold, I should be able to add up each of these frequencies here, and it should add up to 18, the 18 total hours that it was open. So this would be 2, this is 3, this is 8, kind of wrote in here, sorry about that. There's 3, and that's 2. So to double check and make sure that I did this correctly, this should be 18 hours. 8 plus 3, and 3 is 6, plus 4, yep, that's 18. So, all right, we're good to go. If you have questions about that, I would suggest looking at your book, but that's how you create a histogram. And remember, the bars are touching, and you're going to start right here at the 0 so that that first bar goes all the way over to the edge. All right, make sure that you label your x-axis and your y-axis, and also make sure that each of these intervals is the same. Okay, the next type of visual display is a line graph. Probably you all are very familiar with line graphs. And this line graph in particular displays the data. Right here we can see, here's the title, the value of Sarah's car. All right, first of all, notice right away you can see that the value decreases tremendously. So perhaps buying a car is not your greatest investment. What we're looking at here, though, is how a line graph actually helps to show a trend. Typically, that's what line graphs do. They show some sort of trend over time. And so, as you can see, this axis is labeled as the value in dollars. And right here, which is usual that your axis at the bottom, your horizontal or your x-axis, is some sort of time interval, year, 2001, 2, 3, etc. Now, oftentimes we see word problems, and we need to make sure that we understand them. That's the first part of working out a word problem. So let's read this. Sarah bought a new car in 2001 for $24,000. The dollar value of her car changed each year as shown in the table below. Okay, here's the table that they gave us. And we created a line graph to go along with it. All right, so in 2001, the value of the car, $24,000. Awesome. But look at this. 6 years later, look at how much that car's depreciated. And that's actually what depreciation means. If you're not familiar with that word, it just means that the car's value has decreased. So the question here, though, is how much did Sarah's car depreciate in 5 years? Well, if she sold her car in 2006 for its value, what percent of the original price would she receive? Okay, we have two questions going on here. First of all, how much did Sarah's car depreciate in 5 years? All right, here is the time that she bought it. So 1 year, 2 years, 3 years, 4 years, 5 years. So we're talking about 2006. In 2006, her car is only worth $10,000. So in order to determine the depreciation, what do? Okay, take our $24,000, which was its original value, and subtract the $10,000, which is what it would sell for 5 years later. When we do that, we see that the depreciation is $14,000. That's a lot of depreciation in only 5 years. Now, if she sold her car in 2006 for its value, what percent of the original price would she receive? Okay, here we go. We just worked with percent in the last chapter. So now her car sold in 2006 for its value. All right, so the value is 10,000. That's what we know. If she sold her car then for its value, what percent of the original price would she receive? All right, do we know what the original price is? Yeah, right here. The original price is $24,000. So the question really says 10,000 is, so we put it on top, what percent, remember percent over 100, of the original price, which is $24,000. Okay, cross multiply and you can figure out that answer. But again, what's important to notice or to note about a line graph is it has a title, it shows a trend, and all of these are equal intervals. It's 1 year. We show a trend over time, and whatever our value is over here, again, is even intervals as well, 5,000, 10,000, 15. So each time that we move up a space here, we're moving up $5,000, 5,000, 5,000, 5,000, etc. Okay. Another way of predicting trends is using a scatter plot. Now, with a scatter plot, each of these dots represents data. And all I really want you to note about scatter plots in particular is the trends that they show. Oftentimes when we have data and we're working with a scatter plot, we might want to draw a circle around your data points. And anytime that you see a line in this direction going from left to right increasing, that shows a positive correlation. In other words, if we were to say that this point right here, x, was let's say 1, and right here my y is 2. So when x is 1, y is 2, right? So there's my point right there. Well, I'm going to increase x, and I'm going to increase my x to 2. Well, when I increase my x to 2, notice that my y increases slightly as well. It's not 2, it would be maybe 2.4, okay? Or what about this point right here? If I, sorry, hold on, okay? If I were to draw dots down to my x-axis, I might note that this dot corresponds to x of 3 and y of maybe 4. So again, a positive correlation means that as x increases, y increases also, which gives us this trend line that goes in that direction. The opposite is a negative correlation, where again, if we draw, just kind of lasso these dots here, this point right here may represent a y of, say, 8 and an x of 2, okay? But notice that as my y decreases right here, okay, I'm going to come over, maybe this is a 4, my x increases. Instead of the x being a 2, now my x is maybe, I don't know, a 7. Okay? So as my y as my y decreases, my x increases. So you see a trend line that goes in this direction. That indicates a negative correlation. Other times you might see scatter plots where your dots are just all over the place. And even if I were to put a little lasso around here, it doesn't look like much of a trend line. All right, so let me go back. A trend line is going to look something like this, where it goes through the points. Okay, or like this, going through my points. Well, notice here, I'm not going to be able to really put a line through this because they're so scattered. The variance is larger, much larger than these. Okay, so this would indicate no correlation. So again, all you really need to know is that if it goes in this direction, it's a positive correlation. Headed down towards, as y increases, x decreases, that's your negative correlation. And then scattered all over is no correlation. Note here too that I put in your book, page 621, if you're having trouble with scatter plots or if that doesn't make any sense to you, please make sure you refer to your textbook, page 621.